All right, let's kind of recap the stuff we've done previously before we get into some new stuff. Okay, just to make sure we're kind of getting all this together. So number one, rewrite in exponential form. Very good. If we don't see a base, what do we know it is? It's a 10. Those darn unspoken numbers in math. That one's a 10. Yep, so loopy swoopy would be to rewrite it as 10 to the negative 2 equals 0.01. Does that make sense? That is actually what it equals. Because how would you read this number? As a fraction, what would that be? 100th. That's your 100th spot. And if I did this, that's 100th. The negative would push that 10 to the bottom, and 10 squared is 100. So it's 100th. All right, number two, rewrite in logarithmic form. I think you guys are meaning it, but you're saying it slightly wrong. So you would write log, what's the first number I'm going to write? An 8, and that'd be log base 8 of 2 equals 1/3. It could be. I know, I have to add that in, right? It's a little painful sometimes. I'm like, I think you know what you're supposed to do, but it's not how it's coming out of your mouth. All right, but you guys noticed as we go through these, it's always the over, it's always the equals part, right? The over the top was the equals 0.01. Over the top was the equals 1/3. So every time you go over, that's your equals. Okay, so number 3, log base 7 of 343 equals what? So again, what is it asking you? Perfect, that's what it's asking, right? It's doing your loopy swoopy thing. It's saying 7 to what power is 343? 3. So then you would tell me it's 3, right? Like this equals 3, because 7 cubed is 343. Make sense? And then number 4, log base 81 of 127. Again, what's it asking? Right, loopy swoopy. So it's asking 81 to what power gives me 1/27. Right away I know it's what? I know it's negative because my number has moved to the bottom of the fraction. So I know it's negative. And I'm trying to go from an 81 down to a 27. If you do like the square root or the cubed root or anything, does it give you a 27? This is one of the harder ones, like the homework last night had a harder one on it. What number do we know that I can do something with to get me a 27? But 9 to some exponent's not 27. We know 3 cubed is 27. Can you break 81 down to a 3? 81 to what power gives you 3? I want you guys, this is a hard one. I want you guys to kind of see what's happening here. So this is like 3 cubed on the bottom, right? So can you turn 81 into a 3? The 4th root of 81, is that what you're saying? So the 4th root of 81, do you guys agree, is 3? You have a calculator in your hand. Is the 4th root of 81 3? You had this look on your face like I was speaking a foreign language to you. All right. So if I do the 4th root of 81, that gives me a 3. And then how do I turn it into a 27? How do you turn a 3 into a 27? Yes, you have to cube it. Try that. Type in 81 to the negative 3/4 power. See what you get. That's a tricky one. That'd be like a bonus question. Change it to a fraction. 1/27. That was a hard one. That'd be like a bonus. All right. It'd be like a bonus. Your exam questions would be more like something like this one. Like, could you do this? Okay. But it's kind of fun to throw some harder ones out there every once in a while. It is. All right, so for today, we're going to look at properties of logarithms. All right, we're going to work on, I know some of you guys love the rewriting process, right? You're like, you were cool with going from one form to the next form, back and forth. But we're going to work on that again today. But we're going to be in log form, but we can take one log and I can expand it out into many logs so that then I can hopefully maybe simplify at least parts of them. Or I could take a big long one and I can condense it down to something smaller. All right, so the properties of logs, they're similar to your properties from exponents. It's kind of what I always relate them back to. So if I have log base A, whatever my base might be, of two things being multiplied, I can split those with a plus sign. The log will stay the same though. Okay, I'm not changing the base on my log. That log just kind of follows, but I can split it so it's in two different pieces. So multiplication, when I split them apart, becomes addition. Think of exponents. If it's a multiplication problem, what do you do with your exponents? You add them. So to me, that kind of makes sense. That's how I always relate it back to it. If it's a division problem, think about exponents. You subtracted them, right? If it's division, I can rewrite it as a subtraction problem. So this same log base is the same. I'm just kind of taking every piece and just splitting it apart piece by piece. Now granted, are these held together with a plus or minus? Okay, if it's held together with a plus or minus, I can't split that. Same way I couldn't touch it before to cancel things. I still can't touch it. I can't break them. So if you do see that, that doesn't split. But if it's being multiplied, I can split it with addition. If it's being divided, I can split that with subtraction. All right, and then you also have, this one to me is like the most fun property. I don't know why, but I just enjoy this property. It's your power property. If whatever thing you have has an exponent on it, that exponent gets thrown out in front of the log. See, it's out here. It's no longer here, it's out in front as multiplication. Think about when you had exponents to exponents with your exponent properties. Exponent to exponent, what did you do with them? You multiplied them, right? Like if I had x squared to the fourth, what would you tell me that is? It's x to the eighth. Exponents, you went ahead and multiplied. So I have the exponents, we're going to throw it out in front as multiplication with that. I don't know why that one just amuses me. I like that property. Right now we're not, if it would simplify to a number, yes, you would just multiply it. But for the most part, a lot of times it doesn't simplify, so we're just going to throw it out in front. We're working on just the properties of taking them apart and putting them together so that if we had more time, we would get into solving and it would help with that process. Okay? We just don't have time. I'd have to shove it down your throat so fast that you would, like your head would explode. So it's not worth it. So we're going to instead take our time on this stuff. All right, so what is the expression written as a single logarithm? In other words, can you condense it? So right now it's split apart. Can you put it back together using those properties? Yes, it's the same idea. So sometimes it's easier to see them with numbers, okay? So I see a subtraction, which is going to imply I have division. So my log bases, they should always be the same. When you're condensing, I'm rewriting this with a single log. It's log base 4, so I'm going to use log base 4. You're always going to use exactly what you see. And it says 32. And then instead of minus, that implies division 2. Okay, log base 4 of 32 over 2. Can you simplify that a little bit? Yeah, that's log base 4 of 16. Can I do anything with that? What's log base 4 of 16? It's 2. It's asking you 4 to what power is 16? It's 2. If you can, keep going. Now, will you always be able to do that? No. I'd say probably more often than not you can't, but it's exciting when you can. You can keep going. That's probably the biggest thing we may struggle with today is knowing, do I keep going or do I stop? But you always want to look for it. If you obviously had a variable somewhere in here, I'm done. I can't keep going with that. But if you have just numbers, yeah, always check. Can I go ahead and simplify it? Now, if it doesn't go pretty, don't try to like find a weird fraction or decimal to go with it. Just if it goes nice, then go for it. All right, number 2. See the number out in front? What does that imply? What property, where does this go? It's an exponent to this. So it's still log base 2. It's going to keep the same log. Right, the property we just looked at on the previous one said if it was an exponent, it went out in front. So if I'm putting them back, it comes back as an exponent. So that is x to the 6. Right, you got to pull those back in as exponents. A plus sign implies multiplication. So multiply by y to the 5th. I put parentheses, but would I have needed them? No, I wouldn't have. Right? If the number's out in front, that is an exponent to whatever's attached to that log. Now, since I have variables in there, I know I can't really like try to do the loopy swoopy to get an answer. 2 to what power equals x to the 6th, y to the 5th? That doesn't make any sense. So I would be done here. Yes? Mm-hmm. Number 3. Right? So what's the first thing you should probably write down? Log base 4. Because I know it's going to keep whatever that log is. All right, the very first one, there's no number out in front, so there's no exponent. I have just a 5x. Plus implies multiplication. There's no number out in front, so no exponent. 3x. Yes. What x squared? Log base 4, 5 times 3 is 15 x squared. So I couldn't actually do loopy swoopy to get a number, but I could clean it up some. Yep, it's just a multiplication problem. Yeah, the plus implies multiplication. And if I can multiply, great. Up here, it was just x times y. I couldn't really do much else with that. Number 4. Doesn't multiply by the 6. It's an exponent. So I'm going to write down log base 4. I'll go one step at a time just so you can kind of see what I'm doing. But the number in front comes back as an exponent. So that's 6 squared. Minus implies division. And that's just a 9. Okay. I can go further with that, right? Log base 4 of 6 squared is 36 over 9. Does that divide nice? Yeah. So log base 4 of 4, that is 1. Because 4 to what power equals 4? 4 to the first. To me, they're just more fun when they actually go further and you get a number. Just right. Now, do you make a cursive L or do you just make a line? Cursive. Nice. Yeah, because if you don't, like, it looks weird. Like, it could look like 109 if you wrote it funny. All right, so we had them out and we brought them in. Can I start with them in and spread them out? Using the properties just the other direction. All right, so how many times on number 5 will I have to write log base 3? Twice. How did she know that? How many pieces are being multiplied or divided? There's 2 pieces. I have this piece and this piece. Okay, so I have log base 3. What do I do with this first 9 squared? The exponents go out in front, so there's going to be a 2 in front of this. And then a 9 goes there. It's multiplication, so what do I write? Plus. Exponent, again, goes out in front, so you're going to have 4 log base 3 of 2. Yeah, sometimes they get real big and there's a lot of pieces. It's just a matter of those 3 properties, just keeping those ones straight. When do I add? When do I subtract? When do I throw it out in front? So can I clean any of this up? So start here. 3 to what power equals 9? 2. So this whole piece here becomes a 2. Do I still have this? So that gives me 4. 3 to what power equals 2? Is that a nice one? No. So that one's just going to stay 4 log base 3 of 2. If it's not nice, don't try to force it. Okay? But you always want to, after you expand or condense, you always want to look, can I go further with loopy swoopy with a nice number? So number 6. How many times will I write log? Twice. I have a 16 being multiplied by the x part. So I have two pieces. So log base 2, 16. And that's being multiplied, so I write plus. It has an exponent. So that has to come out in front. So 3 log base 2 x.
You don't write that 3 up front?
I did. It went out in front of that piece, right? A log gets attached to every single piece being added or divided, or I'm sorry, multiplied or divided. Can I clean anything up? 2 to what power is 16? It's 4. 2 to what power equals x? Yeah. Again, if I see an exponent, I don't have to worry about it. If you forget to write that little base number, is that okay? No, that's wrong. Because if I don't see a base, I assume it's what? 10. Yeah. On this one? This one? 2 to what power equals 16? It's 4. So log base 2 of 16 is 4. So we're just trying to clean up anything we can. Mm-hmm. Are you on number 6? Are you okay? This is a multiplication problem between the 16 and the x part. Right, there's two things being multiplied. Well, first we did that at the first part. Okay. And then for the x part, exponents get thrown out in front. That's why it's the 3 went out in front of x. I cleaned up this log because it's asking me 2 to what power equals 16? It's 4. It's right there. That was from this. The 16 is attached to this. If I just gave you log base 2 of 16, I said evaluate that, you'd be like, oh yeah, 2 to what power is 16? It's 4. Like it literally is just 4. Because 2 to the 4th is 16. That's where the 4 went.
I just don't know where, like...
You're asking me where the 16 went.
Yeah, in the second problem. Is it just gone after you do the first thing?
Yeah, you're splitting it into pieces. The same way as this one, I used the 9 on the first one, I used the 2 on the second one. I'm splitting with every log, every piece that's being multiplied or divided together.
16 is the first thing in the second one.
No. Because I'm splitting this. This is two parts being multiplied, this part and this part. So I do a log with the first one, and then I do a log with the second part. If I had a lot of pieces, I'd have a log on every single piece that was being multiplied together. So the more things being multiplied, the more pieces of logs we have. And you can build that log cabin you want. Let's do some more. You know how it is in math. Sometimes just the more you see, the repetition makes it stick. All right, log of 6 over 200. Does that bother anybody right off the bat? It is a fraction, but could that be simplified before I even start? Yeah, 6 over 200 is, ugh. It'd be 3 over 100. Yeah, simplify that first. So really I have log of 3 over 100. What's your base? 10. If it makes you feel more comfortable, you can write it in. If you don't want to, you don't have to. It's totally up to you, whatever you're comfortable. All right, how many times will I write the word log? Twice. I have a 3, and it's being divided by the 100. So I'm going to put a log with the 3. I'm going to put a log with the 100. Okay, I got to put it on both. So I'm going to have log base 10 of 3 minus, because it's division, log base 10 of 100. Yes. The first one I'm asking 10 to what power is 3? I can't do anything with that. But the second one, 10 to what power is 100? That's 2. So log base 10 of 3 minus 2. It'd be atrocious to try to type in. It'd be a lot. Yeah.
So once you get it out, it's about the whole thing.
Mm-hmm. And I can't always do it, but we always check. Yep. Okay, let's look at number 8. How many times will I write the word log? Twice. Because I have a 1 being divided by the 147. I have 2 pieces. So I'm going to write log twice. So I have log base 7 of 1. It's being divided, so that implies subtract. Log base 7 of 147. Questions there, and just using the property to split it. Should I be not clear on what we're doing? Okay. Then we're going to kind of use what we learned yesterday and see if can we simplify them. So this first one, again, is asking 7 to what power equals 1? 0. Anything to the 0 power equals 1. Can I do this one? 7 to what power equals 147? Oh, it looked like it had such potential, right? Like you thought maybe? Yeah. So minus log base 7 of 147. Would I need the 0 there? No. If you put it there just because it makes you feel all warm and fuzzy, great. But you don't have to. But you kind of get working through it, whatever. Yes, the negative would still stay there. But if it makes you feel better to leave the 0, leave the 0. Yep, totally fine. Totally fine. Expand each log expression. So let's work on it again. How many times will I write log? 3. Because I have a 5, I have an x piece, and I have a y piece. So there's 3 pieces. I will write log 3 times. All right, so log base 4 of 5, first piece. It's being multiplied, so I'm going to write plus. Now this one has an exponent on it. Where does the exponent go? Comes out in front. So 3 log base 4 of x, right? We just moved that out in front. Still have the x. Say that again. Oh, yeah, it's like to the first. But I mean, if I multiply something by 1, does it change anything? Yeah. So if you want to, that's fine, but you don't have to. And then that's being multiplied by y, so I write plus log base 4 of y. Yeah, some of them get real long. Then the question after we expand it is, can you simplify anything? 4 to what power equals 5? Is that a pretty one? No. 4 to what power equals x? 4 to what power equals y? No. So I'm done. There was no simplifying to be done on that one. I expanded it with hoping I could, but nothing happened. It would be wrong. Yeah, when you expand a log, literally log goes on every single piece. That's why the first question I keep asking you is how many times will I write log? Why don't you guys try number 10? Okay, so number 10. How many times did you write log? 3 times. All right, so we should have written log. What is the base? It's 10. How many of you wrote 10? Okay, majority of you did. You don't have to, but you can. So 10 of 3 plus, yeah, the exponent comes out in front. So 2 log base 10 of x plus log base 10 of y. Did any of them simplify? No. So we were done right there. How many got it right? Score. You got, yeah, me? Monty? Oh, okay. I didn't see your hand. I'm like, oh no, what did she write? Beach ball. It's a beach ball. Last time we taught this, it was spring semester last time we taught this. Okay. So expand each log expression. So we're still expanding. But, there's a little more going on. We really need to kind of talk about one part here. So number 11, how many times will you write log? 4 times. You have a 4, an x, a 3, and a y. All of them get split. Now, there's 2 different ways you could do this. And personally, I don't care which method you choose. Okay? I think one method's easier than the other, but we'll see what you guys think. Jonas? Yes. So let's start there. So we're going to start with log of 4. Then that's being multiplied by the x. So plus log of x, and then I'm dividing, right? Now, here's where it would change. You have two options here. So option 1, I can write the minus for divide, and I can put the whole next part in parentheses, because I need all of it to be on the bottom. But how often do we forget our parentheses? A lot. That's option 1, to do parentheses, but I think, again, it gets confusing sometimes. So a rule of thumb is if it's on the bottom of your fraction, you're subtracting it, because it's dividing at some point. Okay, and I want to show you both. Log, first part, and then also it's dividing by minus log of y. That's probably easy. It's like, okay, minus. But the other option, just for this part here, would be to write a minus, and then you're like, okay, log of 3. And you're like, wait, 3 is being multiplied by the y. So it'd be plus log of y. Are these the same? Mm-hmm. This one has the negative distributed, right? One's not. So that's where, depending on how you feel, because you're like, that's multiplication, so you want to put the plus sign. But in order for it to be on the bottom, there's got to be a minus in front of it. So you can either subtract and always put your denominators in parentheses, or you can just go with the rule of thumb. If it's on the bottom, it's always a minus. So whatever you're more comfortable with. Does not matter to me. What do you guys think? Parentheses or no? Parentheses? Parentheses? No? Doesn't matter? No, it doesn't matter. Either way. But notice the signs are different, though, depending on which option you choose. Yes? It breaks it down just like I was doing with you. It's got the answers. In case I'm too lazy to write it, I can just pull it up. Yeah. I didn't write the 10. You can. I was just being lazy. Yeah, no. Do any of them simplify? 10 to what power is 4? 10 to what power is 3? No, none of those. None of those simplify. All right, number 12. Number 12, how many times will you write log? Twice. I have an x and I have a 729. I only have two things. All right, so let's go through it. So we're going to have log base 9. Yes, there's an exponent, so it has to come out in front. And then I have the x. What's the division? Minus. Log base 9, 729. If it's just one thing, you wouldn't have to. If you have multiple pieces, you would need it in parentheses. Now, if you would put them, though, and you don't need them, it's okay. It's not going to be wrong. Does 9 to some power equal 729? 3. Okay, so we would rewrite this as 4 log base 9 of x minus 3. You guys seem to be doing okay, yeah? Yeah. You could write negative 3 plus 4 log base 9 of x. Is that what you're asking? Yeah. Move my next problem out from underneath my recording. Log base 3 of 9x to the 5th. Why don't you try this on your own? All right, guys. So here we go. How many times did you write log? Twice. Come back to me, guys. Focus. So we had to write it twice, right? We did log base 3. The first piece was 9. That was being multiplied, so plus. Exponents go where? In the front, so 5 log base 3 of x.
So it's always x.
It's an x because there's an x right there. Yes, this is asking 3 to what power is 9? Well, that's 2. So 2 plus, 5 log base 3 of x. Yay? All right. Oh, what are those things? Things you don't like. I want to try to get through this, give you time to work on homework, guys. There's a like that. But this whole process works on exponent. What's a radical half? It's 1/2. Right? So this is log of 3x to the 1/2 over 7. Right? Radicals, square roots can be written as 1/2. If it was a cubed root, it would be 1/3. So you guys are really good at that part. All right, so we're just switching it back as an exponent instead of a radical. Okay. So what does the 1/2 go to? Which pieces? The 3 and the x. So to make your life easier, rewrite it so it's written that way. So log of 3 to the 1/2 x to the 1/2 over 7. If we see it on both, that makes it easier when we go to write this expanded. Yes. Yes. Very good, Riley. All right. So how many times will I write log? 3 times, because there's 3 pieces. Christian? Yes. All right. So if I'm doing my log with the 3, yes, it's going to be 1/2 log of 3, right? I did it for the first piece. I have to do the log on the second piece. What symbol goes in between here? A plus, because they're being multiplied. We're going to have 1/2 log of x minus, because it's division, and then log of 7. I just did them right in order. Do any of them simplify? What's my base? 10 to some power equal 3? That's an x. 10 to some power equal 7? No. Okay, so I'm good here. But do you see how I had to make sure that that 1/2 went on the 3 and the x? Because they both were technically underneath that radical. Okay, so number 15. How should we rewrite the problem before we even start? It'd be log base 5 x to the 1/2. Do I need parentheses? Does that 1/2 go on the 2? No, because that's not under the radical. How many logs will I write? I will write 2. Okay? So the first one I'm going to write with the first piece, which is just the 2. So log base 5 of 2 plus, because it's multiplication, 1/2 log base 5 of x. Yeah, don't forget those exponents always get thrown out in the front. 5 to some power make 2, and that one's an x. It's just a matter of using those properties. Expand them out, put them back together. Expand them out, put them back together. Can you condense it? We've been expanding for a while. Did I miss one? Oh, sorry. It was down low. I didn't see it. Sorry. It was lower. I didn't even notice it was down there. There we go. Yes, let's do 16. All right. Does any of them need to be rewritten before we start? Yeah. If you have a radical, we got to rewrite those. So this is, okay, log base 3 of 5, and then it'd be x to the, where do roots grow? It'd be 2/3. Remember, roots are underground. They're the bottom part. You doubted yourself, didn't you? Yeah, when we rewrite those, roots grow underground, so the root number is underneath. All right, so if you see radicals, first thing, rewrite them with exponents instead of a radical. How many logs will I write? I will write 2. So it's log base 3 of 5. What symbol? Plus, because it's multiplication. What do we do with exponents? Up in front, so 2/3 log base 3 of x. Can I do 3 to some power equal 5? No, and that one's an x. So I'm done. So if you have a radical, should you panic? No, just rewrite it with an exponent. All right, we've been expanding for a while. Can we put them back together? Can we condense them? Got to kick you back and forth, back and forth. So we know this entire thing should be written with how many logs? 1. If you're condensing it, it means I have 1 log. So if I have half log x, what does that imply? It's x to the half power, which is the square root of x. Right, and let me show you that. So, right, the number out in front is an actual exponent, and we know half power actually means the square root of x. And then what is this? What is this number? That's an exponent up here. I was getting there. It goes to the entire. Remember, this is a plus sign. I can't do anything with that, right? So it's going to stay there, and that's cubed. And we're good here that this was a plus, so that's why I multiplied them. And they're all variables, so I don't really have to worry about anything else. Yep, taking it right back. Just using the properties to put it back together. There's not another one hiding, is there? No. How many logs when I condense? How many times do I write log? I write it once. Log of, good, x plus 2 squared. If you got something with a plus sign, like I can't touch that. So that just comes back as its exponent. Minus, do I write log again? Just x. Yep. Brackets are just more powerful parentheses. You know that, right? So all it's saying is that this 1/3 out in front, 1/3 out in front implies it's a what? It's an exponent. That means this exponent goes on everything. That's all it's saying. It goes to everything. So when I write this, it's going to be log base 2. I only have to write log once if I'm condensing it. So since it's out in front of the entire thing, that means this goes on every single part. So it's going to be x to the 1/3. Plus sign is multiply. And then this also goes over here. X plus 1 to the 1/3. And I don't like fractions for exponents. Yeah. Can I put them both under the same cube root together? Yep. So that's the cubed root of x and x plus 1. I can throw them both underneath. And again, if I have variables, I don't have to worry about trying to loopy-swoopy to simplify. How are we doing? I think that was the end as far as I want to go. Yeah. What? You don't know?